In this video, we're going to talk about first principle differentiation of sine x and cos x. We already have the questions on the screen, so I'll just simply write out solution here. So the first one on our list is we are going to differentiate sine x using the first principle. So I'll say y is equal to sine x here. The next thing we do is to add change in x and change in y to both sides of the equation. So to y, I'll add change in y. This will be y plus change in y. To x, I'll add change in x. So this will be sine open bracket x plus change in x. From here, I'll look to make change in y subject to formula. So this will be change in y. That means I'll be moving y over to the other side. If I move y to the other side, it becomes negative. So change in y is equal to sine open bracket x plus change in x close brackets minus y. Now remember from the beginning, y has a value of sine x. So I'll plug sine x as y here next. So this is equal to sine open bracket x plus change in x minus sine x. And then this is change in y. Now at this point, we need to bring a trigonometric identity to help us solve this problem. Anytime we have, say, something like sine x minus sine y, we can write this same term as a trigonometric identity that means 2 cos x plus y over 2 sine x minus y over 2. So anywhere we have something like this, we can write this to replace it. So that's what we are going to be using to help us solve. Now in this case, the x here can be seen as this one here, and the y here can be seen as this one here. So trying to copy this trigonometric identity exactly, we have change in y is equal to 2 cos open brackets x plus change in x plus x divided by 2 and close brackets, then multiplied by sine open brackets. Now we have x plus change in x minus x over 2. Before I continue, I'd like to clean up this space here, so that from here, if I continue simplifying, I have y is equal to 2 cos. Now at this place, I have x plus change in x plus x. Now x can add up to x, so it becomes 2x plus change in x divided by 2. So they have 2x here plus change in x divided by 2 multiplied by sine open bracket. Now in this place, we have x here cancels out to minus x. What we are left with is delta x over 2. So this is delta x over 2. Now that we simplified both sides of the equation, the next thing we do is divide both sides by delta x. So this can be written as y divided by delta x is equal to 2 cos 2x plus delta x over 2, and then this is sine open bracket delta x over 2 divided by delta x. We can rewrite this part of the equation, but before we do that, I want to show you something. Say we have something like 2w over 4. We can rewrite this as saying w divided by the denominator 4 divided by 2. Okay, so that's what I want to do here. Now I'll rewrite this as equal to cos open bracket. Now I can distribute the denominator to each of these terms here. So this will be 2x divided by 2 plus delta x divided by 2 sine open brackets delta x over 2 divided by the denominator becomes delta x. Remember, 2 was multiplying everything here, so I say divided by 2 here, so that I can write this as equal to cos. This cancels out this, 2 cancels out 2 here. It's because of x plus delta x over 2 times sine delta x over 2 divided by delta x over 2. Okay, so this can be written as divided by 1 here. This is still the same thing as this. Let's clean up space and continue our solving. So at this point, remember that this is delta y over delta x. But since we are looking to differentiate, what we are actually looking for is dy dx. And dy over dx is equal to the limits as delta x approaches 0 of delta y over delta x. Now, since we're talking about limits, there's an important fact that I want you to know about limits. If you're taking the limits of, say, x approaching 0 of two values, you're taking of x and y, this can be rewritten as the limits as x approaches 0 of x times the limits as x approaches 0 of y. You can take the limits of the two values individually and then times the final answer. Okay, so that's what we're going to do here. This will be the first one we'll take the limits of, and this will be the second one we'll take the limit of. Let me clean up space. So now that we know that, we can simply write dy dx is equal to the limits as delta x approaches 0 of cos x plus delta x over 2 times, we take the limit of the second one, so the limit of sine open bracket delta x over 2 divided by delta x over 2 as delta x approaches 0. So as delta x approaches 0 here, this becomes 0. So for here, the limits as sine of delta x over 2 divided by delta x is automatically equal to 1. In case you are confused, this value here simply relates to the idea that anytime you have, say, a limit of sine of theta over theta, and the theta is approaching 0, the answer is equal to 1. So if you notice, the theta here can be replaced with delta x over 2 here, delta x over 2. So that's simply why our answer here is equal to 1. Okay, so let me clean up the space and continue my analysis. So that from here, I have dy over dx is equal to, as I've taken the limit here, this is straight up cos x, this side is cancelled out, and then times. Since the limit of everything here is 1, so this is times 1. Then this is equal to 1 times cos x is cos x. That's it for this one. Now you can pause the video and try to differentiate for cos x. Okay, let me clean up space and then jump into example 2. So for example 2, you ask to differentiate y is equal to cos x from first principle. The first step we take is add up delta y and delta x to both sides. So we say y plus delta y is equal to cos open bracket x plus delta x. The next step will be to make delta y subtract the formula. So I'll say delta y here is equal to cos open bracket x plus delta x minus y. Now y is simply cos x, so this is cos open brackets x plus delta x minus cos x. So this can be rewritten as a trigonometric identity. Now, the trigonometric identity in mind here is that whenever you have something like cos A minus cos BE, so if you notice, this looks exactly like this. You can rewrite this as a trigonometric identity of minus 2 sine of A plus B divided by 2 sine of A minus B divided by 2. So what we do now is to take this minus 2 sine A plus B over 2 sine A minus B over 2 and use it to replace this trigonometric identity here. So on to the next, we say delta y is equal to minus 2 sine. In this case, if you notice, your A value very much resembles x plus delta x. So that's what we'll use here. We'll say x plus delta x. The B value is x. If you compare the two equations, the B value is x. So we say this is plus x divided by 2. And then we say sine of open brackets x plus delta x minus x divided by 2. Minus x here cancels out, plus x here, and then you have x here adding up to x here. But let's clean up space and continue analysis. So that we have delta y is equal to minus 2 sine. Now, this x adds up to this x here, So we can say this is 2x plus delta x divided by 2 sine open bracket delta x over 2. So now that we simplified everything, we can divide both sides by delta x. So if I divide here by delta x, I divide here by delta x. This can be written as delta y over delta x is equal to, now like we did before, we can move this 2 down and then simplify this bracket. So if we do that, we have minus sine open bracket x plus delta x over 2. Okay, so here we have times sine delta over 2 divided by delta over 2. Let me clean up the space. dy dx. So dy dx is equal to the limits as delta x approaches 0 of delta y over delta x. So if I take the individual limits here, I have dy dx as equal to the limits as delta x approaches 0 for minus sine open bracket x plus delta x over 2 times the limits as delta x approaches 0 of sine delta x over 2 divided by delta x over 2. So if I take the limit here, this goes to 0. If I take the limit here, all of this goes to 1. So that dy dx is equal to minus sine x times 1. This simply means that our dy dx is equal to minus sine x. So that's it. That's how to differentiate sine x and cos x based on first principles. If you like the video, give it a thumbs up, share with your friends, and subscribe to the channel. Thank you for watching.